faulty ballast can indeed cause an overcurrent in HID lighting systems. The ballast is designed to regulate the current flow to the lamp. If the ballast malfunctions, it may allow excessive current to flow, leading to the 15-amp breaker tripping. The starter plays a crucial role in igniting the lamp by providing a high voltage pulse to initiate the electrical discharge. Grounding the starter is essential for safety, ensuring that the high voltage pulse is dissipated safely. Without proper grounding, the pulse can create electrical noise or interference. Loose brackets can also contribute to the problem, allowing the ballast and starters to move and create intermittent connections, disrupting the electrical flow and causing current fluctuations. To troubleshoot this issue, firstly inspect the ballast. Disconnect the ballast from the circuit and use a multimeter to check its continuity and resistance. If the ballast fails these tests, replace it. Secondly, test the starter. Disconnect the starter and use a multimeter to check its continuity. If the starter fails the test, replace it as well. Thirdly, secure the brackets and connections. Ensure that all brackets are securely fastened and that all connections are tight and not loose. Fourthly, check the voltage at the ballast terminals to make sure it is within the specified range for the ballast. If all these steps fail to resolve the issue, consider replacing the suspected components one by one until the problem is resolved. Also replace all ballasts and starters with identical models to ensure compatibility. The current jumping to 26 amps when the light tries to start indicates a potential issue with the inrush current or a failing component drawing excessive current. The repeated tripping of the 15-amp breaker after only 10 to 15 minutes suggests a sustained overcurrent condition, not just a momentary surge. Here is a more detailed breakdown of troubleshooting steps. For ballast inspection, use a multimeter to test the ballast input and output windings for continuity. An open winding indicates a faulty ballast. Also check the resistance of the windings against the manufacturer's specifications. A significant deviation suggests a problem. Look for any signs of physical damage to the ballast, such as bulging, cracking, or burn marks, which are indicators of failure. To test the starter, also known as the igniter, use a multimeter to check for continuity. An open circuit indicates a faulty starter. Some starters have a built-in capacitor which can be tested for proper function using a capacitance meter if available. Visually inspect the starter for any signs of damage, such as cracks or burns. For securing brackets and connections, ensure that all mounting hardware for the ballasts and starters is tightened properly to prevent movement and vibration. Check all wire connections for corrosion or damage. Clean and tighten any questionable connections. Use dielectric grease on connections to prevent future corrosion. For voltage checks, measure the line voltage at the circuit breaker to ensure it is within the acceptable range, typically 120 volts or 277 volts depending on the system. Measure the voltage at the ballast input terminals with the circuit energized. It should match the ballast's rated input voltage. Check the output voltage from the ballast to the lamp during startup. It should be a high voltage pulse, but verify it is within the manufacturer's specified range. To understand why loose grounding can cause issues, grounding provides a low impedance path for fault currents, protecting equipment and personnel. A loose or improper ground can result in erratic operation of the starter, causing flickering or failure to ignite the lamp. The high voltage pulse from the starter can create electromagnetic interference, EMI, if not properly grounded, affecting nearby electronic devices. Regarding replacing components, if the ballast and starter tests do not reveal any obvious issues, consider replacing them as a preventative measure, especially if they are old. When replacing the ballast, use a ballast that is specifically designed for the type and wattage of the HID lamp being used. An incorrect ballast can cause overcurrent and premature lamp failure. Ensure the new ballast has the same voltage rating as the existing system. When replacing the starter, use a starter that is compatible with the ballast and lamp type. An incorrect starter can cause ignition problems and damage the lamp. Verify that the starter's voltage and pulse specifications match the requirements of the HID lamp. Also, consider the type of breaker used. A standard 15 amp breaker may be insufficient for HID lighting due to the high inrush current during startup. Consider using a slow blow or time delay breaker, which is designed to handle temporary overloads without tripping. Check the breaker's amp interrupting capacity (AIC) rating to ensure it is adequate for the electrical system. If the breaker is old, it may be weakened and prone to nuisance tripping. Consider replacing it with a new breaker of the same type and rating. When dealing with multiple lights on a single circuit, the total load can exceed the breaker's capacity, especially during startup. Calculate the total current draw of all the lights, including the ballast rated current, to ensure it does not exceed 80% of the breaker's rating. If the total current is close to or exceeds the breaker's capacity, consider splitting the lights onto multiple circuits. Also, inspect the wiring. Check the wire gauge of the circuit wiring to ensure it is adequate for the current load. Undersized wiring can cause voltage drop and overheating, leading to breaker tripping. Refer to the National Electrical Code, NEC Table 310.15 for proper wire sizing based on ampacity. Check all wiring connections, including those at the breaker, ballast, starter, and lamp holder, for tightness and corrosion. Loose or corroded connections can cause increased resistance and heat. For the type of HID lamp being used, different types of HID lamps, such as metal halide, mercury vapor, and high-pressure sodium, have different electrical characteristics and ballast requirements. Ensure that the ballast and starter are compatible with the specific type of lamp being used. Check the lamp for any signs of damage or end of life, such as blackening or discoloration. A failing lamp can draw excessive current. If the lamps are old, consider replacing them all at the same time to ensure consistent performance. If the problem persists after checking all the above points, it could be due to external factors. Voltage fluctuations in the electrical supply can cause HID lights to behave erratically and trip the breaker. Use a voltage recorder to monitor the voltage over time and identify any sags or surges. Electrical noise or interference on the circuit can also cause problems. Try using a line filter or surge suppressor to clean up the power supply. In some cases, the issue may be related to the electrical panel itself. Check the panel for any signs of damage, overheating, or loose connections. Ensure that the breaker is properly seated and making good contact with the busbar. If you are not comfortable working with electrical systems, consult with a qualified electrician. High voltage HID lighting requires specialized knowledge and safety precautions. Be sure to disconnect power before working on any electrical components. Use appropriate personal protective equipment (PPE), such as safety glasses and insulated gloves. Follow all applicable electrical codes and safety regulations. If the lamps are controlled by a photocell or timer, ensure that these devices are functioning properly. A faulty photocell or timer can cause the lights to turn on and off erratically, potentially contributing to the overcurrent issue. Check the wiring connections at the photocell or timer for tightness and corrosion. Ensure that the photocell is not shaded or obstructed, as this can cause it to switch the lights on and off unnecessarily. If using a timer, verify that the settings are correct and that the timer is not malfunctioning. Also check for moisture or water damage. Outdoor lighting fixtures are exposed to the elements, which can lead to corrosion and electrical problems. Inspect the fixtures for any signs of water ingress, such as rust or water stains. Ensure that all seals and gaskets are intact and properly installed. Check the lamp holders for corrosion or damage. Replace any corroded or damaged components. If the fixtures are equipped with ventilation openings, ensure that they are not blocked, as this can cause overheating. Consider upgrading to LED lighting. LED lights are more energy efficient, have a longer lifespan, and do not require ballast or starters, eliminating a potential source of failure. LED lights also have a lower inrush current than HID lights, reducing the risk of breaker tripping. When replacing HID lights with LED lights, ensure that the new fixtures are compatible with the existing wiring and voltage. Remove the existing ballast and starter from the circuit when installing LED lights. When dealing with thermal issues, HID ballasts generate heat during operation, which can contribute to premature failure if not properly ventilated. Ensure that the ballast is mounted in a location with adequate airflow. Avoid enclosing the ballast in a confined space without ventilation. Check the ambient temperature around the ballast to ensure it is within the manufacturer's specified range. If the ballast is located in a hot environment, consider using a ballast with a higher temperature rating. Check the wiring insulation for signs of heat damage, such as cracking or discoloration. Replace any damaged wiring. Consider using heat-resistant wiring for high-temperature applications. Another thing to consider is harmonic distortion. HID lighting can generate harmonic currents, which can cause overheating of neutral conductors and other electrical equipment. Use a true RMS, root mean square, multimeter to measure the harmonic content of the current. If the harmonic distortion is excessive, consider using harmonic filters to reduce the harmonic currents. Ensure that the neutral conductor is properly sized to handle the harmonic currents. Check the electrical panel for any signs of overheating or damage related to harmonic distortion. When inspecting the lamp socket, check the lamp socket for corrosion, damage, or loose connections. Clean or replace the socket as needed. Ensure that the lamp is properly seated in the socket and making good contact with the terminals. Use a lamp socket that is rated for the type and wattage of the HID lamp being used. Check the socket's voltage rating to ensure it is compatible with the system voltage. If the lamp flickers or does not start, try replacing the socket with a new one. If the lighting system is controlled by a building automation system (BAS) or lighting control system, ensure that the system is programmed and functioning correctly. Check the control system settings to ensure that the lights are being switched on and off at the appropriate times. Verify that the control system is not sending any erroneous signals that could be causing the lights to behave erratically. Check the wiring connections between the control system and the lighting fixtures for tightness and corrosion. Consult with a qualified technician if you suspect a problem with the building automation system. When dealing with multiple circuits, if the lighting system is divided into multiple circuits, check each circuit individually to isolate the problem. Use a circuit tracer to identify the specific circuit that is causing the breaker to trip. Check the wiring and connections on the affected circuit for any signs of damage or overheating. Verify that the load on each circuit is within the breaker's rating. Consider using a separate breaker for each lighting fixture to improve reliability and simplify troubleshooting. If the lighting system is connected to a generator, ensure that the generator is functioning properly and providing stable voltage and frequency. Check the generator's output voltage and frequency with a multimeter. Verify that the generator's capacity is sufficient to handle the load of the lighting system. Check the wiring connections between the generator and the lighting system for tightness and corrosion. If the generator is not functioning properly, consult with a qualified technician. Always remember that working with electrical systems can be dangerous. If you are not comfortable performing any of these troubleshooting steps, consult with a qualified electrician. Also, always de-energize the circuit before working on any electrical components. Use appropriate personal protective equipment, such as safety glasses and insulated gloves. Follow all applicable electrical codes and safety regulations.